In this lesson, we're going to be exploring how steep our lines are. This line over here is not as steep as this line here. You can see that this one goes up more than this one. But we can't just say that it's steeper, so we need to come up with a figure that explains how steep a line is. And basically what we tried to do is work out for every one step across our line, how far do we go up? For every one across, how far do we go up? So you can see on this line, our steepness is just 1, because every time we go across 1, we go up 1. So our gradient equals 1 in this case. Because remember, gradient is just another word for the steepness. Over here, every one step we go across, we go up 2. One step across, we go up 2, etc. So we know our gradient in this case equals 2. Every time we go across one step, we go up 2. Let's have a look at this one here. For every one we go across, we go up a little bit, but it's not a definite number. I'm not really quite sure. We go across another one, I'm not really sure how far I've gone up. I know it's not quite 1. It looks like it's a half, but I'm not really sure. So the best way to do this is just keep going across. Let's change colour. Let's have a look at here. If we go across 2 squares, you can see we go up 1. We go across 2 squares, we go up 1. We go across 2 squares, we go up 1. So if we go across 2 and up only 1, then it means that we're only going up half each time. 1 across, half up. 1 across, half up. Because we're going 1 up for every 2 across, so we can just sort of cancel that down. So our gradient in this case is a half. Over here on these other ones, you can see that these ones slope in a different direction. Instead of going uphill like these ones are going downhill. So they're what we call a negative gradient, but we still do the same thing. We still look at how far across and how far up or down we go. So in this case, if I go across 1, I'm going down, but I'm not really sure how far. I'm going across 1, I don't really know how far I'm going there. So we need to come up with a different way of doing this. We need to come up with some definite points. Now I know I'm definitely going through there, and I know I'm definitely going through that point. So let's have a look and see how far across I need to go, and in this case how far down I need to go. So I'm going 1, 2, 3, 4 across and 3 down. So every 4 steps across I'm going 3 down. So our gradient in this case is 4 across and 3 down. Now what we do for our equation is we go how far across, we want to go how far across, and we divide that into how far up or down we've gone. So if you have a look here, we've gone across 4, and instead of going up, we've actually gone down, so we make that minus 3/4. So our gradient, I'll write about it a bit neater, is minus 3/4. We talk about how far up, how far across. In this case, instead of going up, we're actually heading down. We're going down 3 spots, so we represent that by a minus. Let's have a look at the next one. If we go across 1, we're going down 2, across 1, down 2. So our gradient here, using our little formula that we came up with before with the up or down, how far up or down, how far across, we're going down 2 for every time we go across 1. So our gradient is minus 2. One more, let's have a look. 2 points that we know we're going through, that one there and this one here. I don't know, these aren't definite points, so I can't do anything with those. So let's go how far across, how far down in this case. So our gradient, we're going down one spot every time we go across. 1, 2, 3, 4. So our gradient is negative a quarter. We could write that as negative 0.25 because a quarter is 0.25, but you can just leave it as a quarter. So what we've done there is talk about how far up and how far across. You'll also see it written as rise over run. The gradient is rise over run. So this is a really important formula. This is how our book explains it, but you can just think about it as how far up, how far across. So let's look at that. 2 points that you know your graph is going through is here and here. So we can make a triangle. We know we're going across one, we're going up 1, 2 spots. So our gradient, which is rise over run or up and across, doesn't matter which way you think about it. I'm going up 2 spots, across 1 spot. My gradient is 2. Over here on the purple line, let's have a look here. If I go across 1, I don't have a definite spot. I don't know where I've gone. So let's find another point. There it is. So let's have a look. Across, and in this case down. So I know I've got a negative gradient. 1, 2, 3, 4 spots across. 2, 3 spots down. So my gradient, rise over run. Now my rise, I've actually going down 3 spots, so I'll put a negative 3. My run is 4. Negative 3/4 might be written as negative 0.75. Same thing. Now you might be asked to find the gradient of a line that's put on an axis. You're going to do exactly the same thing as what we did in the previous slide. If we want the gradient of the line AB, find AB, here it is, and we need to start by coming up with a triangle joining those 2 points and work out what our rise and our run is. Now we've gone from -1 to 3 here, so we know we've gone across 1, 2, 3, 4 spots. Our rise, we've gone from 2 up to 10. 2 to 10, we've got a rise of 8 spots. So our gradient, which I'm going to start calling M, only because it is represented by M quite a lot in our book. Don't be scared by it, it just means gradient. We know it's rise over run. So our rise from our graph is 8. Our run is 4. If you go to your calculator or just do 8 divided by 4, you know your gradient is 2. Fairly simple. We can extend this even further by getting the equation of the line, because if you remember, if we want to get the equation of the line, we just need to use this y equals mx plus c. If you recall from our worksheet that we did, our equation is represented by our gradient is the m, and this c was just the y-intercept. It was just where the graph cut the y-axis, which in this case is here. So it's a really simple extension to go on now to get the gradient of our line. Let me just get my pen back. Our gradient of our line is the equation of the line y equals, put your gradient in, which we've already found up there, 2x, put your y-intercept, which we've found here is 4, There, we're done. So the gradient, the equation of this line is y equals 2x plus 4 is the equation of that line. Let's try another one. Find the gradient of the line CD. Here's C, here's D. Join them up with the triangle. Now you'll notice that CD is sloping down the other way, so you should be thinking that I have a negative gradient before you even go any further, because it is sloping the other way. So to find our gradient, we need rise over run. Now we've gone from 4 up to 8. There's, 4 up to 8 is a distance of 4. Then we've gone from here 0 across to 7. So we have a distance of 7. Rise over run. Now our rise is not a rise, we're going down. So remember, we write a -4 over our run of 7. And that's it. You can't go any further than that. -4 over 7. You could try to get a decimal, but it gets a little bit messy. Let's extend that by actually getting the full equation. The full equation of the line, remembering we need y equals the gradient times x plus the y-intercept. The y-intercept in this case, where it cuts the y-axis, is here at 8. So I'm going to put an 8 in there, and I'm going to put my gradient of -4 over 7 in there, and then I'm done. So y equals -4/7 x plus 8. Finished. That's the equation of the line. So from this lesson, you've worked out how to get the gradient, and you've also worked out how to get the y-intercept, and then use that in getting the equation of the line. There's a couple of other little things that we need to know. First of all, if you've got lines like this, which are either horizontal or vertical lines. Now, keeping in mind what we've just been doing about rise over run, with our first line xy, let's have a look. Our line is flat, it's horizontal. The rise is actually 0. We haven't risen up at all, it's staying flat. Doesn't matter what our run is. Our points here have gone from -1 to 2, so we've got a rise of, run of 3. Doesn't really matter what this number on the bottom is. If you get your calculator and do 0 divided by anything, you're going to get a gradient of 0. So horizontal lines always will have a gradient equal 0. Let's have a look at MN. Keeping in mind again that the gradient is always rise over run. Here's our point here. We've got a rise from -2 up to 1, so I've got a rise of 3. Our run is how far across. Now here, we're not going across at all. Our run is 0. Grab your calculators. Anything divided by 0, you're going to find it is undefined. So vertical lines always have a gradient that is undefined. To get the equations of these lines, it's actually really simple. If you have a look at the line xy, keeping in mind y equals mx plus c, the gradient of xy was 0, so we're going to go y equals 0x plus the y-intercept, which is 5. 0 times x is just 0, so we get y equals 5 as our equation. For the line MN, y equals an undefined gradient. I don't even know what that means. We can't actually do anything with an undefined gradient times x. It doesn't actually mean anything. Let's just look with using some common sense. Forget about the y equals mx plus c and all that sort of stuff. On this line, it cuts